Okay, this is more of homework 4.3, and this is number 25, and we had some particle motion, and we want to find, this is the position function of a particle, x as a function of time, t, is the position, on the x-axis. We want to think of this as the x-axis, and it's going to be t squared minus 4t plus 3. They want you to find the velocity and the acceleration, and then they want you to describe the motion of the particle. So the particle is given by this function as a function of time. So if I take the derivative of the position function will give me the velocity. So that's just going to be 2t minus 4. So it's the a part. And the velocity, the derivative of the velocity, acceleration, the derivative of that's just going to be 2. So there you go. All right. So C equals, and C we want to find we want to describe the motion of the particle. Well, let me see, where do I start? So I just take the position when time is 0. So when time is 0, what's the position? Well, I can put 0 in here, 0, 0, 3. So I get 3, no problem. So I start at 3. What's my velocity when I start at 3? That's nice to know, the velocity. If I put 0, when I'm at 3, the time is 0. So at time 0, what's my velocity? Negative 4, that means I'm going to be moving to the left. My acceleration at 0, if I put 0, it's 2, so I'm going to be having a positive acceleration, so that's going to be pulling me to the right. So I start moving to the left, maybe I had some kind of force pushing me to the left, and then the acceleration is going to be pulling me to the right, so it's going to slow me down eventually. When do I stop, or when does that acceleration pull me to the right enough to slow me down from this initial velocity? Well, I just know that my velocity will be 0 when I stop, so I set this equal to 0, and that's equal to 2. So when time is 2, I'm going to stop. So I'm going to move to the left for 2 seconds. I'm going to stop. Now, where do I stop? Well, I can put that 2 into my position function. That's the nice thing about the position function. It'll give you the position at any time. So if I put 2 in there, 2 squared minus 4 times 2 plus 3 is 4 minus 8 plus 3, which is 7 minus 8, which is negative 1. So my position at 2 seconds will be negative 1. So here, I drew a little graph. What happens? I start at 3. That's when t is 0. And I'm going, something pushes me to the left at a velocity of negative 4 units per unit, whatever. And this acceleration 2 is going to slow me down. So I'm going to start like this, and the acceleration 2 is going to pull me this way until I stop at 2 seconds. And at 2 seconds, I happen to be at position negative 1. And then I've stopped, and then this acceleration of positive 2 starts pulling me to the right thereafter. So if we want to write this down, we can say right over here at t equals 0 times 0, the particle begins at position 3 and moves to the left. At t2, at t seconds, after 2 seconds, it stops, or at t equals 2, the particle at position negative 1 stops, and then moves to the right thereafter. Okay? So think about that. You might want to write that in different words. You might say at 0, at the initial time, or t0. Particle begins at position 3 and moves to the left. After 2 seconds, you might say after 2 seconds, the particle stops at position negative 1, or at negative 1, the particle stops, and then starts to move to the right and moves to the right thereafter. Something like that. Okay, let's take a look at number 27. You get both these in. This is another same type of problem, just a different position function. It was a cubic. I thought I'd have some more interesting things going on, but it didn't work out that way. Okay, so this is the position function. So first of all, I find the velocity the same way that by taking the derivative of the position function. That's just going to be 3t squared minus 3. And that was the a part. That's the velocity. The acceleration was the derivative of the velocity, so the derivative of that's just 6t. So again, the same thing as in the last problem, 25. Where do I start? Well, x sub 0. Again, I start at 3. Okay, x sub 0. If I put 0 in here, 0, 0, 3. And my initial velocity is negative 3. If I put a 0 in for I get negative 3. So I'm moving to the left, negative 3. Now my initial acceleration is 0, but as time goes on, the acceleration increases. So acceleration is not just a constant as in the last problem. It's going to be a function of time. So after 1 second, the acceleration is 6. After 2 seconds, it's 12. So as I move this way, the acceleration starts pulling me to the right a little bit faster and faster. At first, it's not happening right at first, but after 1 second, it starts to pull. After 2 seconds, it's pulling more, so it's going to bring me back. Even though the initial acceleration is 0, it's going to be gaining as t gains. Now, where do I stop? Well, that's when the velocity is 0, so I just set this equal to 0. And I end up with 1. So actually I stop at 1. Well, after I stop, pardon me, actually I stop after 1 second. Now, where do I stop? Well, I put that back in the initial function, and I get 1 cubed minus 3 times 1 plus 3, and that just ends up being 1. So I stop at position 1 after 1 second. So I start here. I've got an acceleration I've got a velocity pushing me to the left, but as I move, the acceleration becomes greater and greater and greater, because as time goes on, the acceleration increases, so I only make it to 1, position 1, after 1 second, then I stop, and then I start moving to the right. And I'm going to actually be accelerating thereafter. So you can write over this. At t equals 0, or 0 seconds, the particle begins at position 3 units to the right, or 3, positive 3, and moves to the left. After 1 second, or at t equals 1, the particle stops at position 1, and then moves to the right thereafter. So that describes the motion, I think, pretty good. Now think about these, because these give you kind of some good insight into the physics aspect of our calculus.